Good day, all. Our topic today is Introducing Educational Statistics. I am Keshi Patricia Mere Somonu, Professor of Educational Evaluation, Research and Statistics, now at Gwe University. Today we are going to talk on statistics, introducing statistics. We have our learning outcomes as follows. At the end of the topic, the student should be able to conceptualize statistics, list and explain types of statistics, define educational statistics, discuss applications of educational statistics, explain how to choose statistical procedure for data analysis, discuss levels of measurement with example. What is statistics? It is a science of organizing, analyzing, interpreting, and presenting data. It uses mathematical techniques to summarize and describe data, draw conclusions, and make predictions. It is used to communicate or present our results and findings. Types of statistics. There are two major types, descriptive statistics and inferential statistics. So what is descriptive statistics? They are used to describe or summarize data. Examples are measures of central tendency, measure of dispersion, some measures of correlation. So the statistics you use in organizing, describing data, we classify them as descriptive statistics. Then we have inferential statistics. Inferential statistics are those statistics used to make generalization or inferences. They are used to generalize from sample statistics to population parameters. Inferential statistics are used in educational research to test hypotheses, make predictions, estimations, comparisons, among other things. It helps us, or they help us to use our sample to draw conclusion on the population. So when you collect your sample, your data from the sample you have selected by population, it is inferential statistics that will help you to move from the data from the sample to the population, because what you are studying is population, actually not sample. But because in many times we cannot study the entire population, we take sample. And when we take sample, the descriptive statistics will help us to use our findings from the data to take decision in the population. So what is educational statistics? It is the application of statistical methods and techniques in collection, organization, analysis, and interpretation of data in the fields of education. It includes using the results of findings to inform education's decision making or inform policy or practices in education. Student assessment and evaluation. We want to look at application of educational statistics. A number of them, we use it in student assessment and evaluation. We use it in research, using statistical methods to study educational issues, assessing the impact of educational interventions, how we train teachers and make them researchers. Another application is accountability, holding all stakeholders responsible for their supposed roles. So ensuring that instructions and individuals are working towards achieving their goal. We also use statistics in program evaluation, that is finding out what is happening in our programs, whether they are effective or not. We also use it during accreditation. Of accreditation, that's evaluating institutional effectiveness, checking compliance to regulations, especially by supervising bodies. Then characteristics of choice of a statistical procedure for data analysis. The choice is based on two considerations. One is the nature of hypothesis. The other is the level of measurement of the variables to be tested. So, nature of the hypothesis. Is the hypothesis testing for difference in mean score between groups or relationship between pairs of variables? These will be explained in detail when we talk about inferential statistics or when we talk about hypothesis testing. Then another issue we need to consider is level of measurement. Levels of measurements are scales on which data are categorized, quantified or measured. You see, numbers has attributes such as magnitude, equal interval between adjacent units, or absolute 0 points. Based on these attributes, data can be categorized or measured on the following scales: nominal scale, ordinal scale, interval scale, and ratio scale. Nominal scale, this is the lowest scale or simplest level of measurement. Here, numerals are used for identification, for simple classification or categorization. There is no magnitude, no number is bigger than or less than other. It does not allow any mathematical applications like addition, subtractions, multiplications, and so on. Examples of these nominal data in nominal scale, like gender. If somebody is talking about gender, you can say, I label male. Once I have male, I put 1, and then female 2. You now see 1 and 2. When you are dealing with that figure that represents male, which is 1, and the figure that represents female, which is 2, you now see that it is simply for identification of a categorization. There is no magnitude, because 2 is not bigger than 1 in that category, and 1 is not less than 2 in that nominal category. Then we have ordinal. Data measured with ordinal scales has magnitude with no equal interval. A number can be greater than or less than another. Then you have something like rank order, sizes of shoes, or students' grades. So you see that there is magnitude. If somebody has A, B, C, there are magnitude. But you now see that the difference or the distance between the score of the person that has grade A and grade C or grade B, they are not the same. And in rank order, you see that if you give people a competition and if they have score, you know that you can say this person is first because it has the highest score. The second person is second, third. You may see that the person that is coming out to have the first rank will have 80. The person for the second may have 60. The third may have 59. So you see that the distance are not equal. But the thing is that once you are first in that rank, you are bigger than the person that came second. Then we have ordinal scale. We have ordinal scale that are measured with okay, we have talked the ordinal scale. Ordinal scale is the one that has magnitude but no equal interval. We now have interval scale. Interval scale has magnitude, equal interval, but no absolute 0 points. Equal interval means that there is the equal distance between the values or the numbers. No absolute 0 point means that any 0 point or mark is arbitrary, not true 0 points. For instance, achievement scores. So statistics can be used to include correlation, all types of t-tests, ANOVA, regression analysis, and COVA. They are all applicable when you have interval scale. Then we now have the ratio scale, the biggest. So ratio scale is the highest scale. It has magnitude, equal interval, points, then an absolute 0.2 or position of nothingness. All measurements in physical measurements are included. Talk of weight, we talk of height. You see that there is position of nothingness. What type of statistics can we apply when we have ratio scale? You see that you apply almost all. Apply t-test there, ANOVA regression analysis, and all types of t-tests. So what are we really talking about now? We are just today introduced statistics, and we know that statistics uh, is what helps us to organize our data, to analyze, and then to interpret figures. And we now see that there are descriptive statistics, and there's also what we call inferential statistics. Descriptive statistics will simply describe your data. But if you come to inferential statistics, you will now see statistics that can help you to move from that data you have just described to talk about what happens in a population. Then question is, what statistics do you use when you are dealing with all these figures? There are two things that determines the nature of the hypothesis. What type of hypothesis are you working on? Are you comparing groups? Are you comparing relationships? So another thing that we also have to play into that choice is the level of measurement. The data you have, at what level is it measured? Is it at ordinal scale or nominal scale or interval scale or at ratio scale? Thank you for watching.